to render light bouncing off water in real time, what we call ray tracing, while pushing a 5K resolution at 240 frames per second, a computer has to perform trillions of calculations every single second. Processing that much math generates a massive amount of heat. Traditionally, handling it required dedicated hardware, towering cases packed with heavy copper heat sinks, cooling fans, and power supplies pulling hundreds of watts. Despite these requirements, you can run those exact same physics simulations and high-resolution textures on a 6-year-old MacBook, or even a basic Amazon Fire TV stick plugged into the back of your television. High-end graphical fidelity has become independent of the specific hardware sitting in a living room. The physical machine actually doing the heavy computation might be sitting in a server rack 300 miles away. This is what that remote hardware looks like. At an industrial scale, data centers use massive, server-class silicon to render game environments in real time. This introduces a strict physical constraint. How do you send a controller input across hundreds of miles of fiber optic cable, render the resulting image, and send that heavy video file back to the player before they notice a delay? Beating latency involves a direct battle against the physical speed limits of data transmission. The millisecond you log into a cloud gaming service, the data center spins up a dedicated, virtualized computer assigned specifically to your session. At the highest tiers, you are taking remote control of an RTX 5080 class system, possessing enough dedicated video memory to output 5K visuals and ultra-high frame rates. To maximize output and keep action fluid, the system uses an AI technology called DLSS4. Instead of rendering every single image, the AI analyzes 2 consecutive frames and generates a new artificial frame between them. By generating these intermediate images on the fly, the server doubles or triples the frame rate internally before the video leaves the data center. The remote server absorbs the entire computational burden, guaranteeing premium visual performance even if your actual monitor is plugged into a cheap, low-power processor. A raw 5K visual feed creates a data volume that exceeds the capacity of a standard household internet connection. To get that image to your screen, the server applies a highly efficient mathematical codec known as AV1 encoding. Here is how AV1 works. It analyzes the visual data and strips out redundant information, shrinking the required bandwidth by about 40%, while keeping color and sharpness completely intact. Once packed down, those tight data packets are fired across the country, physically navigating the switches, nodes, and dense fiber optic cables that make up the backbone of the internet. Advanced mathematical compression allows cinematic graphical quality to survive the turbulent journey from the server farm to your living room. We can map exactly how long this entire process takes. Start the clock the exact microsecond your thumb presses a button on your controller. The input signal races out of your house, hits the server rack, renders the new frame, and instantly reflects back to your display. Under optimal network conditions, that complete logistical round trip takes less than 30 milliseconds. For context, a human eye takes about 100 milliseconds just to blink. The data is moving and processing faster than your brain can biologically perceive a delay. By keeping the transit time strictly below the threshold of human perception, the engineering creates a flawless illusion of local physical play. The Bring Your Own Games model allows users to sign into accounts like Steam or Xbox to access their existing libraries. This setup treats the cloud as a remote access point for software originally purchased for local play. And since the files are stored on the server's end, systems use an install-to-play cache feature that loads 100-gigabyte games almost instantly, bypassing hours of local installation time. This infrastructure supports over 4,500 games across disparate ecosystems. An iPad, a VR headset, and a smart TV can all render the same high-end visuals without hardware modifications. The primary constraint for premium gaming has transitioned from the cost of local hardware to the stability of a user's internet connection. This move represents a change in where digital computation takes place. The heavy lifting of rendering has transitioned off-site. Instead of consumers spending hundreds of dollars every few years to physically replace outdated graphics cards, maintaining top-tier performance just means adjusting a monthly subscription tier. Since the data center handles all the processing, the quality of your local display panel is now the only piece of physical hardware that dictates your visual experience. The physical hardware generating these virtual worlds has been replaced by the high-speed data moving through the infrastructure around us.